Grounding and bonding are essential for electrical safety, ensuring that fault currents can safely return to the source and trip a breaker or fuse. For a main panel, a grounding electrode conductor must be connected to the neutral electrode of the meter socket. The grounding electrode conductor must be bonded to the equipment grounding terminal of the main panel. For a subpanel, a grounding electrode conductor must be connected to the grounding electrode terminal of the subpanel. The grounding electrode conductor must be bonded to the neutral terminal of the subpanel. Ground and neutral wires must be kept separate after the main panel. Metallic conduit must be bonded to the grounding electrode conductor. Let's consider a situation where the grounding wire is not connected to the meter neutral, as required by code. In this case, the neutral bar in the main panel is bonded to the water pipe, which is not an approved grounding electrode. The ground wire is connected to the distribution panel neutral instead of the meter neutral, which is not in compliance with code. To address these issues, let's explore some possible solutions. Firstly, consider pulling the existing circuit from the distribution panel to the main panel with a new conduit that contains a bonding wire. Secondly, install a grounding electrode conductor from the meter socket to the main panel and connect it to the grounding electrode. Then, bond the grounding electrode conductor to the equipment grounding terminal of the main panel. Leaving the installation as is not recommended, as it does not meet code requirements and may pose a safety hazard. The installation does not meet code requirements and should be corrected to ensure safety. The best option would be to either repull the circuit or install a grounding electrode conductor. Grounding ensures a low impedance path for fault current to return to the source, tripping the overcurrent protection device such as a circuit breaker or fuse. This protects against electrical shock hazards. Bonding ensures that all metallic parts of an electrical system are at the same electrical potential. This prevents voltage differences that could cause electrical shock. The National Electrical Code, or NIC, provides specific requirements for grounding and bonding electrical systems. These requirements are designed to ensure the safety of people and property. Section 250.24 of the NEC addresses grounding service supplied alternating current systems. It states that the grounding electrode conductor shall be used to connect both the system grounded conductor, typically the neutral, and the equipment grounding conductors to the grounding electrode. The size of the grounding electrode conductor is determined by NEC Table 250.66, based on the size of the service entrance conductors. For example, if the service entrance conductors are 2/0 American wire gauge copper, the grounding electrode conductor would need to be at least number 4 American wire gauge copper. Section 250.50 of the NEC covers the grounding electrode system. This system must consist of electrodes that are present at the building or structure being served. These electrodes can include a metal underground water pipe, a metal frame of the building, a concrete encased electrode, and a ground ring. Section 250.52 details the specific requirements for each type of grounding electrode. For example, a metal underground water pipe must be in direct contact with the earth for at least 10 feet or 3.0 meters. Section 250.104 addresses bonding of metal water piping and other metal piping systems. It requires that metal water piping systems that are likely to become energized be bonded to the service equipment enclosure, the grounded conductor, the service, the grounding electrode conductor, or the grounding electrode. The bonding jumper must be sized according to NEC Table 250.102. C1 based on the size of the service entrance conductors. Section 250.130 covers equipment grounding conductor connections. It specifies how equipment grounding conductors must be connected to the equipment grounding bus within a panel board or enclosure. The equipment grounding conductor must be connected in a manner that provides a reliable electrical connection. Section 250.146 addresses the use of the equipment grounding conductor for receptacles. It states that the grounding contacts of receptacles must be connected to the equipment grounding conductor. This ensures that any fault current will flow back to the source, tripping the overcurrent protection device. Section 250.32 of the NEC addresses grounding requirements for separate buildings or structures. If a building or structure is supplied by a feeder or branch circuit, a grounding electrode system must be installed at that building or structure. This grounding electrode system must comply with the requirements of Section 250.50. The grounding electrode conductor must be sized according to NEC Table 250.66 based on the size of the feeder conductors. Section 250.92 covers bonding of metal enclosures. It requires that metal enclosures containing service conductors be bonded together to ensure electrical continuity. This bonding can be achieved using bonding jumpers, lock nuts, or other approved methods. Section 314.4 covers the grounding of metal boxes. It states that metal boxes must be grounded in accordance with Article 250. This can be achieved by connecting the equipment grounding conductor to a grounding screw or clip within the box. Section 408.41 addresses the grounding of panel boards. It requires that panel boards be grounded in accordance with Article 250. This can be achieved by connecting the equipment grounding conductor to the equipment grounding bus within the panel board. These code sections provide a framework for ensuring safe and effective grounding and bonding of electrical systems. By following these requirements, electrical professionals can minimize the risk of electrical shock and fire hazards. Understanding these code requirements is crucial for anyone working with electrical systems. Failure to comply with these requirements can result in serious injury or property damage. Always consult the latest edition of the NEC for the most up-to-date information and requirements. Consider a scenario where a subpanel is installed in a detached garage. The subpanel is fed from the main service panel in the house. The feeder conductors are run through underground conduit. The NEC requires that a grounding electrode system be installed at the detached garage. This grounding electrode system could consist of a ground rod, a ground ring, or other approved grounding electrodes. The grounding electrode conductor must be connected to the grounding electrode into the equipment grounding bus in the subpanel. The neutral conductor in the subpanel must be isolated from the subpanel enclosure. This means that the neutral conductor should not be bonded to the subpanel enclosure. A separate equipment grounding conductor must be run from the main service panel to the subpanel. This equipment grounding conductor provides a path for fault current to return to the source. The size of the equipment grounding conductor is determined by NEC Table 250.122 based on the size of the feeder conductors. In addition to the grounding electrode system and the equipment grounding conductor, all metal parts of the electrical system in the detached garage must be bonded together. This includes metal conduit, metal boxes, and metal enclosures. Bonding ensures that all metal parts are at the same electrical potential, which reduces the risk of electrical shock. Now, let's explore a few real-world examples of grounding and bonding issues and how to address them. In one case, a homeowner installed a new subpanel in their basement. They ran the feeder conductors from the main service panel to the subpanel. However, they failed to install a separate equipment grounding conductor. Instead, they relied on the metal conduit to serve as the equipment grounding conductor. This is a violation of the NEC. The metal conduit may not provide a reliable path for fault current to return to the source. In another case, an electrician installed a new service panel in a commercial building. They connected the grounding electrode conductor to the metal water pipe. However, they failed to bond the metal water pipe to the service equipment enclosure. This is also a violation of the NEC. The metal water pipe may become energized if there is a fault in the electrical system. In another situation, a homeowner noticed that they were getting a slight shock when they touched the washing machine. They called an electrician to investigate. The electrician found that the washing machine was not properly grounded. The equipment grounding conductor was not connected to the washing machine. The electrician corrected the problem by connecting the equipment grounding conductor to the washing machine. These examples illustrate the importance of proper grounding and bonding. Failure to comply with the NEC requirements can result in serious injury or property damage. Always consult with a qualified electrician to ensure that your electrical system is properly grounded and bonded. Let's delve a bit deeper into the specific requirements for grounding electrode conductors. According to NEC section 250.62, grounding electrode conductors must be made of copper, aluminum, or copper-clad aluminum. The material must be resistant to corrosion and suitable for the environment in which it is installed. The grounding electrode conductor must be securely fastened to the grounding electrode into the service equipment enclosure. The connection must be made in a manner that provides a reliable electrical connection. Now let's take a closer look at the requirements for bonding jumpers. According to NEC section 250.102, bonding jumpers must be made of copper, aluminum, or copper-clad aluminum. The size of the bonding jumper is determined by NEC table 250.102. C1 based on the size of the service entrance conductors. The bonding jumper must be securely fastened to the metal parts that are being bonded together. The connection must be made in a manner that provides a reliable electrical connection. Consider a situation where a metal conduit is used to protect electrical conductors. The NEC requires that the metal conduit be bonded to the service equipment enclosure and to the grounding electrode. This bonding ensures that the metal conduit is at the same electrical potential as the service equipment enclosure and the grounding electrode. If the metal conduit is not properly bonded, it may become energized if there is a fault in the electrical system. This could create a shock hazard for anyone who touches the metal conduit. Similarly, if a metal box is used to enclose electrical devices, the NEC requires that the metal box be grounded. This grounding ensures that the metal box is at the same electrical potential as the equipment grounding conductor. If the metal box is not properly grounded, it may become energized if there is a fault in the electrical system. This could create a shock hazard for anyone who touches the metal box. Grounding and bonding are not just about following code requirements. They are about protecting people and property from electrical hazards. By understanding the principles of grounding and bonding and by following the NEC requirements, you can help to ensure that your electrical system is safe and reliable. Always remember to consult with a qualified electrician if you have any questions about grounding and bonding. Now consider the specific application of a 200 amp service. For a 200 amp service, the minimum size of the copper grounding electrode conductor, according to NEC table 250.66, is number 4 American wire gauge. If aluminum conductors are used, the minimum size is number 2 American wire gauge. The grounding electrode conductor connects the neutral bus in the service panel to the grounding electrode system, which could be a ground rod, water pipe, or other approved electrode. The purpose is to provide a low impedance path for fault current to return to the source, tripping the overcurrent device and preventing dangerous voltage buildup. For bonding the metallic water pipe, NEC section 250.104, requires it to be bonded to the service equipment enclosure, the grounded conductor, the grounding electrode conductor, or the grounding electrode. The bonding jumper is sized according to NEC table 250.102. C1, which for 200 amp service with copper conductors typically requires a number 4 American wire gauge copper bonding jumper. The bonding ensures that the water pipe is at the same electrical potential as the service equipment, minimizing the risk of electric shock. Let's discuss subpanels further. When feeding a subpanel, it is crucial to keep the neutral and ground conductors separate, as per NEC section 250.32. This means that the neutral bus in the subpanel should not be bonded to the subpanel enclosure. Instead, a separate equipment grounding conductor, sized according to NEC table 250.122, must be run with the feeder conductors to the subpanel. This equipment grounding conductor connects to a separate ground bus in the subpanel, which is bonded to the subpanel enclosure. For example, if the subpanel is fed with number 3 American wire gauge copper conductors, the minimum size of the equipment grounding conductor is number 8 American wire gauge copper. The reason for separating the neutral and ground in a subpanel is to prevent neutral current from flowing on the grounding path. If the neutral and ground are bonded in the subpanel, any neutral current will also flow through the equipment grounding conductor, potentially causing voltage drops and creating a shock hazard. In the specific scenario mentioned earlier, where there is a 100 amp subpanel fed with 4-3 row mix, The equipment grounding conductor within the ROMIC should be connected to a separate ground bar in the subpanel, and this ground bar should be bonded to the subpanel enclosure. The neutral bar in the subpanel should remain isolated from the enclosure. Also, the size of the equipment grounding conductor within the 4-3 ROMICs must be adequate for a 100 amp circuit, as specified in NEC Table 250.122. It is important to note that aluminum conductors require different considerations. When using aluminum conductors, it is crucial to use connectors and terminals that are specifically rated for aluminum. Aluminum conductors also require antioxidant compound to prevent corrosion at the connections. The size of the aluminum grounding electrode conductor and bonding jumpers will be different than the size for copper conductors, as specified in the NEC tables. For example, if using aluminum service entrance conductors for a 200 amp service, the minimum size of the aluminum grounding electrode conductor, according to NEC Table 250.66, is number 2 American wire gauge. Let's also touch upon the importance of ground fault circuit interrupters, or GFCIs. GFCIs are designed to protect against electrical shock by detecting small imbalances in current between the hot and neutral conductors. When an imbalance is detected, the GFCI trips the circuit, interrupting the flow of electricity and preventing a potentially fatal shock. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas. NEC Section 210.8 provides a comprehensive list of locations where GFCI protection is required. In addition to GFCIs, arc fault circuit interrupters, or FSIs, are also important safety devices. FSIs are designed to protect against fires caused by arcing faults. Arcing faults can occur when there is a break in a conductor or when there is a loose connection. FSIs detect the characteristics of arcing faults and trip the circuit, preventing a fire from starting. FSIs are required in many locations, such as bedrooms and living rooms. NEC Section 210.12 provides a comprehensive list of locations where FSI protection is required. Remember that electrical codes and regulations can vary depending on the location. Always consult with a qualified electrician to ensure that your electrical system complies with all applicable codes and regulations. Proper grounding and bonding are essential for electrical safety. By following the NEC requirements and by using qualified electricians, you can help to protect yourself and your family from electrical hazards. When working with electrical systems, always de-energize the circuit before working on it. Use a voltage tester to verify that the circuit is de-energized. Wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electrical systems, hire a qualified electrician to do the work. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself. In summary, always ensure that main panels and subpanels are properly grounded and bonded according to the National Electrical Code. Key aspects to remember are that grounding electrode conductors must be properly sized and connected to an appropriate grounding electrode. Bonding jumpers must be used to bond metallic components, and neutral and ground conductors must be kept separate in subpanels. It is critical to regularly inspect your electrical system to ensure it meets safety requirements.